A programming language is the notation that we use to describe an algorithm or some other computation that we require the computer to perform. There are two imperatives that conflict with each other, making languages close enough to natural or human language that they can replicate how we express ideas, but also close enough to the instructions in the computer's own instruction set. High-level languages are closer to the first goal, while lower-level languages are closer to the second goal. It would take a very large book to list all the programming languages that have been in existence since 1957, when Fortran was first released by IBM. Yet few of us use more than a handful. In my own career, I have learned and used for at least some programming Fortran, BASIC, PL1, Pascal, COBOL, C, C++, Java, JavaScript, Perl, Scheme, and there may be one or two that I have forgotten. That makes less than 10% of the 120 languages that Samet listed, and some weren't even around in 1969. Do we really need to understand the concepts of programming language design and implementation to program in these languages? There are 6 primary reasons to study programming languages. It increases our ability to express ideas and make use of them. It helps us use the right language for the right job. We could use COBOL for artificial intelligence work. I knew someone who did exactly that. But it's like banging in a nail with a screwdriver handle. It will get the job done, but it feels ridiculously clumsy. It makes it easier to learn new languages because we understand that there are certain constructs to look for, and we know what the various paradigms and purposes are. We have a better idea of how to use the languages that we already know, and we understand more about computing overall. Language is our primary tool in shaping the ideas that we form. It's difficult to express and even conceive the ideas without the words to express them, and a way to put these words together. And that is exactly what language is. Ideas need to be transformed into algorithms, and they can't become programs without a language to write them in. Better languages lead to better ideas, which lead to better programming. There is an old saying that when you hold a hammer, everything looks like a nail. People are most likely to use only the languages that they know. Expanding one's knowledge of languages makes it easier to pick the right tool for the right job. Computer science is much younger than most fields of study, and it's still developing, and so are its languages. Knowing how languages are designed and implemented makes it easier to learn new ones. My first language was Fortran. Learning BASIC after Fortran was much easier than learning Fortran had been. That made it easier to learn PL1, which made it easier to learn Pascal, which made it easier to learn C. These made it easier to learn C++ and Java. TOB uses several different metrics to compile their list of popular programming languages. It seems surprising to see C at the top, above Java, C++, PHP, and Ruby. It's very surprising to see Pascal there at all. But there are frequently features and characteristics of a language that lead to this popularity, and these features and characteristics are what we need to know. It's important to understand how a language is implemented to be able to use it correctly. This is especially important when trying to fix bugs in the programs that you have written using that language. A hammer is great for banging in nails, and a screwdriver is better for inserting or removing screws. The same is true for programming languages. If you are doing large-scale calculations, Fortran may be better. For business reports, that might be COBOL or SQL. But this requires knowing something about the languages themselves. Understanding a language helps you learn how to make better use of its features, such as creating arrays and linked lists, or using recursion or object classes. It can also help to understand why some languages become and remain popular, while others are a proverbial flash in the pan. One example of this is Algol 60, a language with far better structure than Fortran had. But Algol's description was not clearly specified, and most computer scientists didn't see the significance of its block structure until many years later. During this time, there was a sizable number of libraries written for use with Fortran. However, eventually, the advantages of block structures became clear, and this led to the popularity of PL1 to some extent, and was one of many factors that led to the popularity of Pascal and C.